So problem based estimation can be done in two different ways. First one is either you estimate the LOC, that is the lines of code required, or you estimate it using the function point. Now there are two different ways. I mean, these are two different activities, LOC based and FP based, function point based. These two activity, the estimation based on these two activities, it differs in its working. So how LOC based estimation works? It basically works using this concept. LOC based concept is basically focused on decomposition. So decomposition is absolutely essential. Decomposition is absolutely essential. How it works? Say you have a broad level of problem assigned to you, and you have been asked to estimate it using LOC based estimation. So you will do, like, a bigger problem is there, you will decompose it into smaller number of problems, Say a bigger problem is decomposed into 5 smaller problems. You estimate for every small problem, you estimate for the small problems, because estimating it for a smaller problem is quite comfortable, is quite convenient than estimating it for a larger problem. Whereas FP based problem, now we have seen how this function point we have calculated. We have calculated function point by considering the number of inputs to the system, by number of outputs to the system, the number of internal logical files which are available with the system, the inquiries available, the reports you will be getting out of it. So based upon these various factors, we calculate the function point. And then with the help of function point, we can estimate. We can generate an estimate. So this is how the LOC based estimation and FP based estimation, how these two based estimation differs fundamentally. Now, regardless of estimation variable that is used, either you use LOC based estimation or FP based estimation, you should always begin by estimating a range of values for each function or information value domain. So a 3-point or expected value then can be computed. So there is a formula which has been given. S is equal to S optimistic, OPT stands for optimistic, SM stands for the most likely or the average scenarios, pessimistic means the worst case scenario, optimistic means the best case scenario. So whatever is your estimation, like you estimate it, like we'll be able, in the best case scenarios, we will be able to finish it within, say, 10 days. The best case is 5 days. So you can say have 5 on an average. So on an average you require 7 days. So 4 multiplied by 7 plus pessimistic means during the worst case scenarios I will be getting 10, and then you divide it by 6. So this is the formula which has been given to consider your worst case, best case and most likely kind of scenarios, and you derive an expected value for that factor which is under consideration. So this is something known as problem based estimation. The next is process based estimation. You divide the number of activities that you are going to perform in this project. Say in this table, this is a sample table. Here we have functions. Function means what you are going to do in your software development process. So first you will going to design a user interface and control facility, then some kind of geometric analysis, then third kind of geometric analysis. Basically these are the various activities for the development of a software which is say that CAD/CAM software. So this is the kind of a software, and for developing this software, these are the various functions which are identified by the team: database management, graphic display facilities, peripheral control function, and other functions which are there. And here various tasks have been listed out. Say CC, say customer communication, then planning, risk analysis, engineering, and so on and so forth. So based upon the time available, based upon the team size, based upon the expertise you have, you can have a more detailed level matrix. This is a kind of a matrix. See here, engineering phase is further bifurcated into analysis and design. Construction release phase is further bifurcated into code and test. Again, you have a liberty to further bifurcate analysis into further parts. You have design, you can bifurcate it into further 2 or 3 sub person month of effort you can estimate. And based upon person month of estimate, you have fixed a cost per unit of effort. Now the next estimation technique could be the use case based. Now we know what is the use case. Use cases basically provides you an what you can say the scope, the desired scope for that particular problem that you are going to work. So use cases basically provides you with the boundary, with various actors who are involved in it. Use case provides you the functionality. Use case provides you the functionality and how these actors interact with those functionalities. Now developing an estimation approach with the use cases is again not a very popular idea. Due to various reasons. Now the first reason could be if a problem is assigned to two use case developers, so they will try to interpret that problem and try to provide solution according to them. So their use cases may vary. So no two use cases are same. So estimating on relying what you can say is you can if your estimate is relying on the use case, and if that use case is not the best use case that is possible, then again your estimate will suffer from your estimate will suffer from setbacks or failures. Now use cases now we have seen that use cases normally deals with the level of interaction. Like these are various functions, these are various use cases, these are various actors, and they will call these functions. But what will happen inside those functions? The complexity of the functions is not available in the use cases. Use cases represent the external view. Use cases represents the external view, the software of the software, and can therefore be written at many different level of abstraction. Since it represents an external view or the user's view, what an actor thinks of, what an actor is allowed to access. So can be written at many different level of abstraction. If 4 use cases are there, then also the system is correct. If 10 use cases are there, then also the system is correct. How much detail you can how much detail or the depth of a use cases to design is still a problem. So unlike the lines of code or a function point, you have a formulas assigned. You have a lines of code or function point. You have certain set of mathematical baselines provided to you. But this is not the case with use cases. So a one person's use case may require months of effort, while other person's use case may be implemented in a day or two. It again depends upon the type of use case they have drawn. An estimation model for a system use empirically derived formulas to predict effort as a function of LOC or FP. Now, since you want to use LOC based estimation or FP based estimation, so there are a set of formulas which have been provided, which have been proposed, and using those set of formulas, you can get your estimation values. So the normally this estimation takes this form: E is equal to A plus B into EV of C, where this E is efforts in person month. E is efforts in person month. This AEV is your estimation variable, whether you are going to use lines of code based problem or whether you are using it function point based problem. And A and B are empirically derived constants. Empirically derived constant means based upon certain set of experiences, based upon the study carried out on similar kind of a projects which have been completed before, the value of A and B is fixed after due research. So these are various values. Say if you are going to use LOC based estimation, and these are certain values if you are going to use function point based estimation. So these are various researches after which these formulas have been provided. Now from these formulas it is clearly seen that for your KLOC, the value of say KLOC, say 5, if you substitute the value of 5 in all the formulas, definitely you are going to get 4 different estimation values, because this 5.2 multiplied by something and 0.91, 5.5 into 0.73 and here 1.16. So even if you substitute the same value, then also you are going to get 4 different estimation values. So which one to use? Again, this is a what you can say, a matter of research. I mean, which formula is best suitable for the problem that you are trying to estimate? Which formula is best suitable for the kind of project that you are dealing with? So you need to study all these things in detail and then carefully choose the estimation formula, So similar is the case with function point based approaches. So even if you calculate the function point and if you substitute here, since all these values are different, you will get 3 different estimate. Say function point is 45 or 50. So if you substitute the same value here, you get 3 different estimate using the function point. Again, which model to use? This is a matter of study. Model. So COCOMO stands for constructive cost model. COCOMO stands for constructive cost model. So constructive का को, cost का को and model का mo, COCOMO. Constructive cost model. So originally COCOMO model became one of the most widely used and discussed software cost estimation model in the industry. And the scientist Mr. Barry Boehm has evolved a more comprehensive model and named it as COCOMO II model. The next generation model, that is COCOMO II model. So COCOMO II मॉडल जो है it is actually a hierarchy of estimation models that addresses the following areas. So COCOMO II model is a model which is composed of various activities. Okay. So first is application composition model. It is used during the early stages of software engineering, when prototyping of user interfaces, consideration of software and system interaction, when you are planning your activities. What are the various activities that you undertake during your early stages of your software development? Prototype. You develop a prototype of the user interfaces. How your user interfaces will be. You develop a prototype. You try to understand, you try to estimate your possible system interaction, how the various components of your system will interact with each other. When you assess the performance of a system, and evaluation of the technology maturity, when you evaluate the technology maturity, when these kinds of factors are at paramount means these factors are at peak, when these factors are under consideration, this application composition model is there. Then early design stage model. After planning, when you are at the early stage of the designing process, once your requirements have been stabilized, you start your system design process. So another model is early design stage model. And post architecture. Post architecture means after your designing gets over. That is during your construction of the software. So these are the three hierarchies of estimation models, which is clubbed together. The knowledge out of these three models are clubbed together to form a COCOMO model. Now let's see how this COCOMO model basically works. We have seen like two kinds of a metric we have seen. One is line of code, that is LOC based and FP based. Here COCOMO model says introduced one more the metric, that is object point based. So let's see how it works. Like when you calculated the function point, we have discussed 5 different factors. Say number of input, number of output, number of external inquiries, number of internal or interface files, and number of output reports. All these 5 factors we have seen, and we have one complexity factor associated with these activities, whether it is a simple, it is a medium, or it is complex, and then we have calculated function point based upon one formula, function point calculation formula. So how this COCOMO model works? This model basically divides the activities into 3 parts. Either one is the number of screens, number of reports, and number of components that is likely to be developed. And this is a sample matrix which has been provided. If you are dealing with a simple kind of a system, then the matrix value is 1, 2, and here null. So let's say you want to calculate, say, the object point. How you can calculate the object point? Let's say you have been given a system wherein you want to develop, say, 5 screen. You want to develop a 5 screen, 2 reports, and say Leslie, let's say 10 components you are likely to build. And the type of system you are dealing with comes into this category, let's say difficult category. So how you will calculate the object point? So 5 screens, you will multiply it by the value 3. Reports, you will multiply it by 8. And components, you will multiply it by 10. You calculate the value, say 15, 16 and 100. You get the sum. Okay. 131. Now 131 is your, what you can say, the object point. You have arrived, you have calculated, you have derived a object point value. यहाँ तक सबकी समझ में आया? The first step of this COCOMO II model is to derive a object point. Now how to derive a object point? Based upon three factors: the number of screens, the number of reports and the number of components. And identifying the type of a system that you are developing, simple, medium or difficult. Then multiplying it with respective weightage and arrive at the object point. Now what this COCOMO model states that you have calculated this object point, but definitely you are going to reuse certain part. Definitely you are going to reuse. I mean, you are not going to develop altogether a new software. Definitely you are going to reuse some existing thing. So you estimate the percentage of reuse. Let's say you estimate that 5% reuse will be there, or 10% reuse will be there. So you calculate NOP. NOP means new object point. So NOP is equal to 131, the object point that you have calculated, into 100 minus whatever the reuse that you have considered, say 5, 10, 15, 20, 30. And then you calculate the value of new object point. 131 multiplied by 100 minus whatever is your value divided by 100. So you calculate the new object point. So once you calculate the new object point, then using this table, whether your developers or experience capability or environment maturity capability comes into which kind of category, these are few standard values which have been provided. Productivity rates have been provided. So you substitute this value in this formula. You have new object point value with you. Person per month, that is the productivity rate you have been provided, and you calculate the productivity value. Now you have calculated NOP value, you have calculated the productivity value, and then using this formula you can calculate the estimated effort. You can get the projected effort, you can get the estimated effort for using the COCOMO II model.